Okay, so we're going to talk about Git and GitHub. So first at a high level, and then we're going to look at some basic commands that we're going to use to maintain our own source code. So we're not going to cover things about collaboration right now when you're working with somebody else on one GitHub repo, but we're just going to talk about things to maintain your own source control right now, which we'll use for morning challenges and other things. All right? So what we're going to talk about is why do we even need version control, first of all. What is Git and GitHub? Some terminology and commands, setting up a repository, and using your own repository. So what Git is it's a distributed source control management system. Distributed means everyone has their own copy of the history. All right? Git works with repositories, and I'll call them repos. Okay? And it has a complete history and version tracking capabilities. Every change that you make and commit is bundled in that commit and associated with a particular person and a date. So we use it in this class and as developers for version control, source code version control. It can be used for all sorts of things, and it is used for all sorts of things, but this is the way we're going to use it. So it will track changes made to the files, the source code files, are parts of our projects. It creates a history of those changes, and it lets you see all the changes that are made with each commit. So you can see it with fine granularity, exactly what change was made, when it was made, and who made the change, which is very useful when you work on a big project, certainly with lots of people. But even if you work on a small project by yourself over time, it's really useful to be able to have that history, to see it, and to roll back if you mess things up, which inevitably you will. So if you are in a good practice of committing your changes, so creating lots of commits, if you totally screw up your source code and it just stops working, so it was working, it will happen so many times, it's working beautifully, you're so excited, and you're like, I'm going to add this cool thing to it, and it's going to be even better. And then you make these code changes to add the cool thing, and then it's all completely broken. And then you're really sad. And you're like, I wish I was back where things are working again. I don't need this cool new feature. I just want it to work again. Please, let it work again. So then you can just roll back to the place where everything was nice and beautiful, and there were rainbows and unicorns. So it is important, though, that you commit often, because you can only roll back at the level of a commit. Okay, so one of the things we'll do in this course is try to instill really good habits about committing often, and that will save us lots of tears one day. So the other thing it does is it allows multiple people to work on the same source code. So you can imagine that if you're not using any kind of version control or any way to keep track of who's making changes and when those changes were made without any ability to roll back, having 2 or 3 or 4 or 10 or 20 people working on the same source code would be a nightmare. It would just be terrible. So it really does make that possible to do in a sane way. So it's really necessary. So the little GitHub guy is so adorable, y'all. Isn't he cute? And there are lots of cool stickers and little icons that have been made of the GitHub guy. I just really like them. So what is GitHub? GitHub is a cloud-based Git system. It is not the only one. There are other ones like GitLabs and Bitbucket. Those are another 2 popular cloud-based solutions for Git that you might run into when you go out and work with someone. So GitHub is probably the most popular for open source development. And not probably, it is the most popular for open source development. A lot of small companies use Bitbucket instead because it's cheaper. And some companies use GitLab usually because of affiliations that they have with other companies and products and things. So GitHub allows us to share things really easily online. It also provides a little bit of a social aspect too. So we can like message each other, leave messages for each other through GitHub. We can sort of interact with the other developers that we're working with on open source projects. So it's a bit of a platform for that sort of thing. And the last company that I worked with was SAP, and we used GitHub. So it is used by big enterprise companies too, and not just for open source or with smaller companies. So wait, because this cartoon is really cute. Did you guys see that? So where did you meet? Windows users at the office, Mac users at Starbucks, because, you know, Mac users so bougie, and then Linux users at GitHub. So Git and GitHub aren't the same thing, but a lot of times those terms are used interchangeably. So I'll talk about Git, I'll say Git, and I might mean GitHub. And I might say GitHub, and I mean Git. And other people will do the same thing. So they mean two different things. They're talking about two different things, but they're used interchangeably, those terms. So GitHub is the popular service that extends Git, the version control software. Git is the version control software. GitHub is a distributed system that manages multiple copies of Git repositories, and it can merge them into various branches. So you can think of GitHub as a front end to Git with a lot of social features added on top. But really, it doesn't matter too much that you understand how to distinguish the two. The way that you use them, they'll be very closely intertwined, okay? So, as I mentioned, we are going to use the command line interface to do all of our work in Git. There will be times that you have to go to the browser, to GitHub. For example, when you want to create a new repository, you have to go to GitHub to do that. If you want to raise a pull request against someone else's repository, you have to go to GitHub in the browser to do that. But everything else, once you've established a connection between your machine and a remote repository in GitHub, everything that you do other than pull requests, you'll do from the command line. Okay? And we'll all get really comfortable with that. So there is a really good cheat sheet, and there's a link there on the slides, so you can check that out. And you probably want to bookmark it so you can look back at it when you forget about the commands that you want to run. So this cartoon is really funny because it's true, but it's not going to be true after you leave this course. But for a lot of people, honestly, a lot of people out there working in the field as developers, this is true for them. So this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool. How do we use it? No idea. Just memorize these shell commands and type them to sync up. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. So true. I've seen so many developers think about Git and GitHub that way. You know, they don't really understand what they're doing or why they're doing it, and they mess things up, and then they're like, I'm just going to get a fresh copy of the repo. You know? So that is not the way that I want you to feel when you leave this course. I want you to feel totally comfortable and confident when you're using Git and GitHub, and know when things go wrong, what you can do to fix them. So let's look at some terminology and commands. So there are these 4 different spaces that we can think about when we're dealing with a Git repository. If we start from the top of the screen, our working directory is what's on our laptop. It's where the files are. It's where we run ls and cd, and we run code to look at the files themselves. The working directory is on our laptop, okay? And it's where we do our work. Working directory is where we do our work. And the working directory for a particular repository is located where that repository is defined on your machine. So when you define a repository on your machine with either git init or with git clone, those 2 commands will define a repository on your machine. It will create a directory, and that directory will contain the repository. And that directory will contain another directory, a hidden directory, named .git. So if you see a directory with a .git file in it, your system thinks that that is a Git repository working directory. Okay? When we do any work with a repository, any work with the source code in a repository, we want to make sure we run our Git commands from the working directory. One of the biggest mistakes that people make is they're not in the working directory. They might be in one directory higher than that. And then they try to run Git commands and they don't see what they expect. Or they might be in a child directory of the working directory, the root directory. And then they try to add stuff to staging and not everything gets added and they don't know why. So when you run any Git commands from your laptop, you want to make sure you're in the working directory. And this will become more clear as we practice with it, okay? But the working directory is on your machine. Now, the way the workflow goes is you'll have a repository. You'll have cloned that repository or initialized it on your machine. You're in your working directory. You're making changes to your files. So you're creating source code files, you're changing those source code files, and anytime you make changes, what is in your working directory becomes out of sync with what's in GitHub. Okay? So what's in GitHub is down at the bottom. That's the remote repository. That's what's out in GitHub. Okay? So as soon as you make changes in your working directory, you're not in sync anymore with your remote repository, because what's in the remote repository doesn't match anymore with what's in your working directory. So when you want to synchronize what's in your working directory to what's in your remote repository, the steps that you follow are: first, you do a git add. A git add will add the changes that are in your working directory to the staging place. The staging place is not a place we can actually see with like commands like ls or any of those sort of basic file system commands. We can see what's in staging with some git commands, but staging is this place that's really in this temporary storage that we don't have easy access to except through git commands, and it will store changes that have been made in our working directory when we call git add. When typically right after we stage changes with add, and the workflow that I'm going to teach you is right after you do git add, you do git commit. Git commit moves those changes from staging into your local repository. This is another special magical place that you can't see directly with any commands, regular file system commands, but you can see with git commands. So your local repository is a representation of your repository on your local machine. And basically what git commit does is it creates a commit which wraps up sort of all the changes that you've added to staging and assigns them this one label. So it'll have this hash value, which is the label, this long like hash key, and it'll have a date, and it'll have your name. Whatever's configured as your Git user and your Git config, your name will all be associated with this commit. Okay? So it's a way to bundle up these changes that you've made. Now for that reason, it's a really good idea to do your adds and commits in small pieces. So the things that are in a commit are the things that you can roll back to. So you want to be in the practice of not making 50 different changes or working on something for 3 days before you do an add and commit, because then you'll have all these changes in there and one of those things is probably wrong, and then you've got to sort through this whole big pile of changes to figure out what was wrong. Whereas if you do smaller commits, then it's easier to isolate where the wrong thing happened. There are some Git tools that will help you isolate between commits where a problem occurred. So commit takes us to the local repository, but it's still not in GitHub. It's not in GitHub until you do a push. So a git push will move commits that are in your local repository into your remote repository. So git push looks at the last commit that your remote repository knows about, compares that to the last commit that your local repository knows about, and it pushes up the commits that are in your local repository that are not in your remote repository yet. Okay? So we'll talk in a lot more detail about what's happening underneath when we do a Git collaboration lesson weeks and weeks from now, probably a couple of months from now. So for now, the things to know are that you'll be running add, commit, and push to get stuff from your working directory into your remote repository. Okay, and we'll get lots of practice. Okay, so this has to be a little more complicated than it needs to be, because if we're using the Coder Academy network, which uses a proxy, What it means is that we can't use SSH connections to our repos, and I really like to use SSH connections to my repos. So the reason I like, so who knows what SSH is? So some people have a, it's secure shell, and do you know why we use it and how we use it? Yeah, so the normal, yeah, so the normal way that we connect to remote machines, so anytime we connect to a Git repository, a remote repository in GitHub, it's off of our laptop. We're connecting to some machine that's out there on the cloud, out there on the network somewhere. When we connect to a remote machine, to a GitHub repository, we have to authenticate. We have to say who we are and what our password is so that GitHub knows that we are authorized to push stuff into this repo or pull stuff out of this repo, right? So we have to have authentication. Now, one way to authenticate is over HTTP. So when you look at GitHub, the URL is HTTPS. It's always a secure HTTP connection. And when we connect to a GitHub repo from our terminal session, if we've set up the connection to our remote repository as the HTTPS connection, we'll use secure HTTP authentication to do the authentication. And that is going to prompt us for a username and a password every time. So every time we do a push, every time we do a fetch, every time we do a pull, it'll prompt us to type in our username and our password, because that's how HTTP authentication works. And it's really annoying. When you're pushing, when you're doing commit, bunches of commits and bunches of pushes, commits are okay because it all happens on your machine, but when you're doing bunches of pushes and pulls, it can get really annoying that you have to keep typing in that information. Yes, Jai?
So if we're on an internet connection that's not using a proxy, can we use the SSH encryption?
Yes, you can.
Okay.
So what SSH encryption allows is we set up a key pair. That's what SSH does. So we generate a key pair on our laptop with SSH keygen. That's the command there. And then that generates a public and private key. We're going to do this together in just a minute because we are going to set up SSH. Oh, cool. All right. I'll let you show it. So we will run SSH keygen to generate a key pair, and then we're going to take the public copy of that key, copy it, and paste it into GitHub. And what that will allow us to do is to use the SSH connection to our repos, and we won't have to type in our username and password every time. It'll use the key to authenticate us instead, which is really convenient and a lot nicer. So what I typically do here, because sometimes I'm using the HTTPS connection if I'm on the Coder Academy network, and sometimes I'm using the SSH connection if I'm not on a proxied network, is I will set up both connections to my repo sometimes, or I'll create them as I need to. It's not hard to do, and I'll use the one that I have to use. So let's create some SSH keys. Does anybody already have SSH keys for their user on their machines? No? If you do, you're free to use those, okay? But if not, then we'll create some. Okay, so I'm going to go back here. So you don't actually have to do all that, Liam. You can actually just type SSH keygen, and that's fine. So I know in the slide I had TRSA and other stuff like that, but you can just type SSH-keygen, and that's it.
Space dash?
Nope, just SSH-keygen, no spaces. And then the first thing it does is it asks you for a file, but we're going to use the default file name, so we're just going to hit enter here. And then, so you've already created one, so you don't have to overwrite it. Do you mind overwriting? Have you already copied it out? Okay, so we hit enter. Now the next thing it does is say, do you want to enter a passphrase? We are not going to enter a passphrase, because if you enter a passphrase, you still have to type in a password every time you use your key. And we don't want to type in our password every time we have to use our key. So we're just going to hit enter and empty for no passphrase. Enter again. And what that does is it creates a key pair with no passphrase. Okay? And that shows you the random art image of your key. Isn't that beautiful? Nice random art image. Okay. Now, it's important that you do that in your SSH, in your home directory. Okay, was everybody in their home directory when they did that? That's important. Okay? So now if you're in WSL, only if you're in WSL, okay? We're going to copy this key onto our Windows drive. Now, we could just put it in the C drive, or we could put it in our user's home directory. I'm going to suggest putting it in our user's home directory on Windows, just so we could use the same key from there if we ever wanted to. So that means you have to know what your Windows username is. So you can, does everybody know how to figure out what your Windows username is if you're on Windows? If you open File Explorer, do you want to show them that, Liam? If you open File Explorer.
I haven't got that. It's just on the window instead of the whole screen.
Right. Yes. Yes. So if you
I can change it.
So if you're on Windows and you open up your File Explorer, your Windows File Explorer.
Just to make it easier, you can just go to the same app data, the same, and take you straight, just in case your account is hidden, and then you can just click on your actual username there, and it'll be that's it right there.
Nice. Does that make sense to everyone? Or you can just go to C Users. Raise your hand if it's not clear and you're on Windows. So this is only for Windows users. Only for Windows users. So you just want to get your Windows user name, and that will be in your users directory. You'll have a folder with your user's name. Did you find that, Melanie? So if you click on user, this is just called user. Okay. All right. So yours is called user with a capital U. That's the thing to remember. Okay. All right, so now on the command line, what we're going to do is we're just going to copy our keys to our Windows user directory, so we have it in case we have to recreate our Ubuntu environment. So we're going to do a copy -r cp-r .ssh space /mnt/c /users with a capital U / whatever your username is in Windows. So for you, Leilani, that would just be user with a capital U. And for Liam, it's root. Okay, and what that's going to do is just make a copy of this whole directory, because we actually have a directory now called .ssh. So if you show hidden files in your user directory after that, you'll be able to see that .ssh file. Yeah. Awesome.
I do have a problem.
Yeah?
That's my user run. What's that?
Yes. But it has a space in it?
Yeah.
Right. So you just have to put quotes around it? Just put single quotes around that username?
Put your user and not
Yeah, if your Windows username has spaces in it, just put single quotes around the username, and that'll take care of any problems you have with it. Okay, so all we've done is we've saved a copy of our SSH keys in Windows if we're on WSL, so that we have a copy of them. So now what we're going to do is go back to terminal, and if you ls space .ssh, and everybody can do this now. Everybody does this. ls space -ssh. I'm sorry, not dash, .ssh. Enter.
Wait, so it's ls.ssh.
ls space .ssh. And what you should see, two files. One file is called id_rsa, and another file called id_rsa.pub. So the .pub is your public key, and the other one is your private key. Okay? So you never copy your private key out to remote systems. Your private key always just stays on your machine, and you don't give it to anybody, because then it wouldn't be very secure. So that just lives in your home directory on your machine.
Should my ID-RSA, the first one, should that be in green?
Yeah, mine
Nor is mine.
Probably doesn't matter. I'm not sure why it's green. So, so now what we're going to do is just clear your screen, Liam, so you move the cursor back to the top. So now what we're going to do is we're going to concatenate the public key. So does anybody know the command to concatenate a file? It's cat, C-A-T.
Oh,
So C-A-T, and we're going to cat.ssh/id_rsa.pub, the public key, because this is the key we're going to copy to GitHub. So enter. Now the reason I'm using cat is because cat won't put any weird new lines, characters, or spaces, or things like that. If we open this in Windows, or like in a text editor, there's a possibility that we'll get some extra characters in there that we might not even be able to see. But I know if I use cat, it always just prints out exactly what's in that file and nothing extra. And that's really important when we're copying the key. So now, if you'll highlight that key and copy it, and this is for everybody, highlight the key and copy it, put it in your copy buffer. And now what we have to do is we have to go to GitHub. So go to your GitHub account in your browser, and if you click on your little user icon in the top right hand corner and then go to settings, which is near the bottom, just above sign out. And then in settings on the left, you'll see SSH and GPG keys, and we're going to click on that. And then we're going to do, did you already add the key that you'd created before? So you probably want to delete that one. Yeah. So what we're going to do is click the new SSH key button. And inside the key text box, we're going to paste that key. All right, so if you lost it in your buffer, just go back and copy it again. Paste it in there. The title is just a name that indicates to you which machine this key came from. It doesn't matter what you put there, but this key is associated with a specific piece of hardware, your machine and your user. And you can see that actually in the public key itself. Do you see that at the end of the key? It has username at machine name. So this key is only going to work if it's coming from the connection's coming from that user on that machine.
And after that, we just click add SSH.
Yes, you just click the green button. Okay, how are we going with that? Anybody stuck or need some help with that? All good? All right, cool. So what this is going to allow us to do is from our terminal session, we'll be able to connect to our GitHub repos over SSH using the SSH connection string. And we'll look more at those two different connection strings that we can get, either HTTPS or SSH, when we actually clone a repo, which we'll do on Monday. We'll clone the Morning Challenges repo, and we'll all do that together. Okay, cool. Thanks, Liam. So let's go back here. Okay, so we've done all this. All right, so let's look at just a little bit more GitHub terminology and commands that we need to get started. So when we say fork, what we mean is to create your own remote repo from someone else's repo on GitHub with all the history up to the time of that fork. So, for example, with the Morning Challenges repo, I've got a repo that I've created, okay? And it's in the Coder Academy Brisbane account. And I'll get everyone to fork that repo, and that's going to make your own copy of that repo in GitHub under your account. And it'll have all the history of that repo up to the point in time that you fork it, okay? So that's what forking is, and forking you do from GitHub in the browser. You don't do that from the command line. So you fork from GitHub in the browser. And you can fork anybody's repo, all right? Anybody's repo that's public, that you have access to, you can fork anybody's repo and make your own copy of it and then do stuff with it. Yes?
So forking somebody's repo
Mm-hmm.
is just creating your own copy of the base.
Mm-hmm. It's creating your own copy on GitHub under your account. Cloning a repo is when you take an existing repo. It could be your fork of another repo or any repo, okay? Any repo out there in GitHub that you have access to, you can clone it. And cloning is something you do from the command line. So you go to GitHub in the browser and you get the connection string. And this is where you can get either the HTTPS or the SSH connection string. So let me just quickly show you what that looks like. So from GitHub, say for example, if I go to, this is my movie library repo. If I click on this clone or download button, then this is where I get the connection string. So right now it's showing me the SSH connection string, clone with SSH. Use an SSH key and passphrase if you want to use this connection string. Or if I click this, it toggles it to use HTTPS. Okay? So when we want an SSH connection string, we make sure that we grab this one. And you can just click, oops, I just downloaded the zip. That's not what I wanted to do. That's all right. So you can also download the zip, but I never do that normally. So if you just click this little clipboard next to it, it grabs that string. Okay? So we'll go to GitHub, we'll get the string of the repo we want to clone down to our machine, and then we go to terminal, and I'm just going to go into projects for the moment. And then we say git clone, and then we paste the repo name, or the repo connection, and you'll see that it'll clone it into a directory with the same name as the repo. Okay? And if that directory already exists, you'll get an error. It'll say there's already a directory with this name here, and it won't let you go any further. So now if I do an ls, I can see there's this movie library directory that got created, and if I cd into that, now I'm in my working directory for this repo. And I can tell I am because there is a .git subdirectory with all this stuff in it. So ls-a shows me that there's a .git file in here, which tells me that there's a repo here, that I'm in the working directory of a repo, and movie library is the name of that repo. Yes?
So is that the way you would change parts of the code of the repo? Like,
Yeah. So I have a repo on GitHub that I created there either by forking or by creating a new one. And then if I want to clone that repo down to my machine, I grab the connection string, I run git clone. Git clone does two things. It initializes a Git repo in this directory. So it creates the directory, initializes a GitHub repo in it, and then it pulls down over the network, over SSH if I've used an SSH connection string, and over HTTPS if I've used the HTTPS connection string, and it copies everything in that remote repo into my local repository, which ends up with files in my working directory. Okay, so that's what we do with clone. Now by default we have a master branch. So repositories have branches, and we'll talk more about what branches are as we go along, but we can have any number of branches on a repository, and branches allow us to sort of separate streams of work and streams of changes. Companies will use branches for different releases or for fix packs. If we are working together with other developers, then we might want to use feature branching, which is where we create a branch for each feature that we're working on. So it's a way to keep changes sort of isolated from the central code base while we're working on those changes. And then typically, once we get the code tested in those branches, we merge them back into the master branch. Not in every case, but that's typically the workflow that we do. So the master branch is the default branch that gets created on a repository. And the master branch typically is where we hold our pristine code, so our working code. So we generally will make changes on feature branches, test those changes in the feature branch, make sure that we haven't broken anything, and then merge those changes into our master branch after we feel like we're not going to make anybody upset with our changes or embarrass ourselves. Origin is the default name of the connection to the remote repository. So if we look back at this repo that I just cloned and I do a git remote -v, then it shows me I have one connection. I know there are two lines there, but they both have the same name. So I have one connection named origin, and that connection points to this remote GitHub repo. Okay? I can add other connections to it if I want to, and we'll do that with the Morning Challenges repo. So when you clone your fork of the Morning Challenges repo, you'll have an origin connection to your fork, and then I'll have you create another connection to my repo so you can pull down the new challenges every day. So you'll use that connection to my repo to pull down the challenges, and then you'll push up your code to your master branch on your fork. Okay, and don't worry if all that's not completely clear, because it will become more clear and you'll get lots of practice. But this is the basic terminology we have to at least be familiar with to even get started using Git. Okay, I've got another presentation with like 43 slides about collaborating in GitHub, so it gets a lot more complicated, but we don't need to worry about that for at least a couple of months or so. So this is these slides are just about the workflow that I talked about. So if we start from another repo, that's one choice we have. We have an existing repo out there in GitHub, and we want to use that to start from. That's what we do at the Morning Challenges repo. Or if you find somebody else's code or project that you like and you want to have a play with it yourself, then you can fork their repo and start with that. So that's one way to create a remote repo, is to fork it and then clone it down to your machine. And we just talked through that process. Another option is to create a brand new GitHub repo. So if we want to work on something all of our own that we're going to start from scratch, then we can create a brand new repository in GitHub. And we do that with the little plus symbol in GitHub up by your little avatar on the right-hand side. And we say new repository. So we choose new repository. We give it a name and we click create repository. The convention is that GitHub repo names are kebab case. That's what this is called, when you put dashes in between the words, because it looks like they're on a skewer. The words are on a skewer, so it's kebab case. So that's the convention, okay, in GitHub. You can do whatever you want, but that's a convention. You decide to make your repository public or private. So public repositories are available for anyone to see, peruse, fork, and clone. All right? They can't, I don't think they can just push stuff into it. I'm pretty sure they can. Yeah, okay. So they can't make any changes to your repo, but they can take your code. Okay? So if you're just working on something that you don't plan to make money on, you know, and you're not like super, so people feel different ways about their code. Yeah, go ahead, Aiden.
Yeah, make sure that you don't add in like anything that people can like scrape and just
Yeah.
I left a Discord bots token in a
Yes.
repository, and someone was like scraping GitHub and just taking all the public repository
Yes.
tokens.
Yes.
And they keep like everyone from like 15 different Discord servers.
Yes.
Just about had admin.
Yes. So you can store anything in a GitHub repo. Okay. And if you aren't mindful of it, you might store things like encryption keys. API keys, passwords for servers that you set up, or databases that you've put out there. So you don't want to put any of that stuff in your repos, period, probably, but definitely not in your public repos. Okay, so you do want to be conscious that anything you put in a public repo, anybody can have access to. Anybody can look at it and use it. Okay, including bots that scrape for keys and tokens. Yeah,
Do
Joey.
you need a premium account to go private?
You don't anymore.
Oh,
They've opened it up so that you can have private repos. They can only have up to 3 collaborators on them, though. So you can create private repos with a free account. I will look into. I know that you can get free, kind of full functional accounts as a student. So I'll work out how to do that and let you guys know.
All it needs is edu. That's
It just needs an
it. Just
ED.
needs .edu at the end. That's it.
Okay. Or in your username, you don't have to do, or in your email, you don't have to do anything else.
Doesn't matter username, email, just needs edu at the end. That's
At the end of what?
it. Of the domain.
Of the domain. Okay. Of the domain for.
Code Academy, anything, as long as it has .edu, the
Right.
the email domain.
Yeah. Okay. All right. So if you make your repo private, you have to add collaborators if you want other people to be able to see it and to fork it and to clone it. There are other settings that you can set on repositories, but these are the basic settings. Now, when I create a new repo, I never tick the initialize this repository with a README tick box. I always just create my README myself, because typically when I create a new repo, I've already done some stuff on my laptop. I've already created something, a file structure, maybe a file, maybe a README. I've created something typically on my laptop first, and so I want to start with a completely empty repository. All right. So I don't tick that checkbox, and by default it's not checked because I think that's what most people do when they create new repos. Okay, so just leave that checkbox unticked. You don't have to add a Git. I wouldn't add anything by default. Okay, just because typically you've already got stuff in your directory. You should add a README after. Okay, from your working directory. You should add a git ignore in most cases, and a git ignore is used to prevent stuff from being stored in your repo. Okay, so things like config settings maybe that you don't want to be out there for everybody to see. And once we do some Rails and Node development, we might have directories like Node modules that have tons and tons of files in them. We don't necessarily want to push that up to the repo. So we'll talk more about that later. But usually what I do is I just select public or private, depending on how I'm going to use this repo, and click Create Repository. That's it. So if you create a brand new repository from GitHub without a README, if you create it with a README or anything, you have to clone it down. Okay, that's what you would do to get it on your machine. But otherwise, from your terminal, you type git init from the place that you want your repo to live in your laptop, and that will initialize this working directory as a local repository. Okay, and then you can create a README and you can push it up. So let's all just try that now. Let's try creating a new repo. It'll be fun, I promise. So first we're going to go to GitHub. So go to your GitHub, and up next to your user, the little plus sign, click on New Repository. And give it a name.
Can we just have a test?
You can. I'm going to call mine Demo Repo. You can call yours whatever you want. I'm gonna leave it public just because nobody's going to want what I put in here. And so I'm going to leave everything else just the way it is. I'm just going to give it a name, and I'm going to click Create Repository. Now when you've done that, you're going to get a screen like this. And you'll see this screen until you add something to this repository. Okay, so I'm going to use SSH, and we can all do this just so we can make sure SSH key configuration is all good. So click SSH if it's not clicked. So you should have a string that starts with Git at GitHub here. And just click the little clipboard icon to copy that string. And it actually tells you exactly what to do down here. Okay, so if you ever forget, you can just look at what's on this screen and do exactly what it says. You could copy and paste, but we're going to type it in so that we practice learning it at the same time. So now we're going to go back to terminal, and we're going to cd into our repos directory. So you can cd home and then cd repos, and we should be in our repos directory. Yeah? I can make my screen bigger. Okay. This is not doing what I want it to do. Why are you not doing what I want you to do? That's really weird. I'm just going to see if I can make my screen bigger. Why? It shouldn't be this way. I'm just going to open another terminal window. Bear with me for a moment. What's going on? Okay, so inside of our repos directory, we're going to create another directory. And this is going to be the working directory for our repo. So whatever you called your repo, make a directory with that name. What did I call mine? To my repo. So we're going to mkdir, make dir, in the name of your repo. And then we're going to cd into that directory. So now you should be in your repo, the directory that you created for your repo. Everybody there? Now we're going to do a git space init. And this is going to initialize an empty Git repository. It happens really fast. And what it actually did, if you want to look, if you look at ls.git, you'll see it created all this stuff. Just did it really fast. All right, everyone good? Now we're going to create a README file, and I'm going to do that very quickly the way that it suggests to in the instructions we just saw, and I'm going to use the echo command. The echo command just prints exactly what you give it to print, so I'm going to use double quotes and say demo repo. Well, you can say whatever you want. It doesn't matter what you say here. And I'm going to use 2 greater than signs, which says add this thing that I'm echoing to a file, and I'm going to call that file readme, all capitals, .littlemd. So this is the name for the readme file for a Git repo. It's readme.md. Does anybody know what .md files are?
Markdown?
It is. It's Markdown. So if I put, no, we'll just leave it like this. Okay, so everybody have that, and then we just hit enter. Now if you do an ls, you'll see that there's a readme file. And we can use our cat command to see what's in that readme file, and it should be whatever you echoed. Now, Now we're going to move this file, the creation of this file, into our staging. Does anybody remember the commands that we talked about to move things from our working directory into staging? Yeah, git add. So we're going to say git add. Now you have to pass an argument to git add. You can pass it a directory name or a file name, a list of file names. You can actually pass it, I think, like line numbers of files, and you can get really specific. But because I prefer a workflow where I'm adding, committing, adding, committing, adding, committing, after each little change that I make, I almost always just say git add space dot, which says anything that is new here, add it. Okay, it's all right if you've done that, but I'm just going to show you something else. So git status will tell me what is different in my working directory from my local repository. So what it's telling me is that we're on the master branch. Oops, stop. There are no commits yet. Yeah, I know, right? Look at this. It's crazy. Yeah, I forgot that we can do. Where is it? Okay, I'm going to do it now. We can like zoom it from here too. We have an untracked file, which means it's not in staging yet, and it'll show up in red. And it says I've got this readme.md file that the repository doesn't know about, and that's because I just created it. And it tells me if I want to include it to use git add. It tells me exactly what I need to do to get it from my working directory into staging. So if now, I'm going to clear so we get to the top of the screen, I do git add dot. Now if I do git status, it shows me, okay, now you have changes to be committed because I've added it to staging. So now it's sitting in staging and it turns green. And now I can say git commit. Now when you commit, you have to give it a commit message. It'll force you to. If you don't pass the -m flag, it'll open up an editor and something that's probably really frustrating to you because it'll either be a nano editor or a VI editor, and you'll be like, what am I supposed to do in this thing? Unless you're familiar already with nano or VI. So always use the -m and put a quoted message. So this I would usually say first commit. Okay? So when I'm initializing my repo with brand new content, I usually say first commit. You don't have to. You can say whatever you want. Okay? But when you do commits, your commit messages should be meaningful and descriptive of what you're committing. Okay? So when I run this, you can see that it tells me that I have committed on master branch, and that number there is a part of the hash that gets associated with this commit. And it tells me that there was one file changed and it was one insertion, meaning I inserted one line in that file. Okay? So now what I have is this README file is in my local repository now. It's in my local repository, but it's still not in GitHub. Still not in GitHub. It's just still on my machine. You got an error? What kind of error?
It says, please tell me who you are.
Yeah,
We haven't done it.
All right. So somebody who has that error, will you join the, Sam, do you want to join the Hangouts? If you look in Slack, so Liam, if you'll stop presenting in the Hangout. And Sam, if you join, and then you don't have to join the Hangout. Yep. So we'll just get Sam to join so he can demonstrate what he's seeing, and we can all fix it together. I love an error, people. It's beautiful. Okay, so How many people had Git ask who they are? Yeah?
Now I've got my next
All right.
one.
So there is a .git config file in your home directory, or there isn't maybe yet. So and it's called .gitconfig, and it's in your home directory, or not. Git expects there to be one there, and it's going to use the username and email that's in that file to tell Git who is making this commit. Okay? So if you're on a Mac, you might see a slightly different message that says, this is who we think you are, is this who you are, something like that. Does anybody have a slightly different message on a Mac? No? Okay. So I think this is just good for everybody to do. It won't hurt to do this, all right? Because if you're on a Mac, it's possible you have the wrong. By default, I think on a Mac, it'll use the email address and machine name that's associated with your Mac as your username and email address for Git, and usually those are not the same. So everybody can do this now. So what we're going to do is we're going to run these commands one at a time. So git space config -- global. You can copy it if you want, but what's in the quotes needs to be replaced with, in the case of user.email, needs to be the email associated with your GitHub account. Okay? So git config -- global user.email, and then in double quotes the email associated. Yes.
Do we do this even if we got it correct?
Yeah, just do it.
Oh, you can actually check.
You
can check
You
your identity.
you can check. You can. Yeah.
Check git config.
You or the, okay. Yeah. Is it git config
Git config and then user dot
email?
and then I'll
Okay.
just print your email.
Okay.
If what is
All right.
associated.
All right. So if you want to check, it doesn't. But like I said, it's just going to replace whatever's there with whatever you type in here. Yes.
Oh, don't worry. I just.
And you can always do this at any time. So if it gets messed up at any point, you can do this, or you can edit the git config file directly also to make these changes. So there are numerous ways to do it. Yes. From GitHub. Yes. Yes. So go ahead and put your email address associated with GitHub, your GitHub account. Sam?
In quotes or no?
Yeah, in quotes. And then enter. And then git config -- global user.name, and it needs to be your GitHub username. So that whatever name is there when you go to GitHub, and it shows your name either in the
I want to do my name in quotes, yeah.
in the browser address bar. Yes,
I
Jai.
just looked at my email. It's not actually my email, but it didn't give me an error.
It won't necessarily give you an error. You only see this error if you don't have a .git config. You might have a .git config with the wrong information in it.
You might just get a fix it straight up in the tutorial, like had the full email address.
Yeah. Yeah.
So
So you want to set it, just run these commands and set it to what your,
I want to do that in quotes, yeah.
so user.name, Sam, user.name.
Yeah.
And then try the
Does it matter if I do the first replay? Oh, it doesn't matter. So if I go back to home and do that again, it won't matter if I do that. I can check.
So your user.name is whatever shows up in your address bar here or here.
Oh,
That's your username. Yes,
click back on the code.
I will. After you run these two commands,
Yeah.
then I don't think you have to run. Do you have to run a reset or something?
No, you have to say git. Oh, wait, just to check whether it worked.
Yeah.
You just like git config user.name. And then
Okay,
it'll
so-
switch your name back to you.
Yes.
If it works.
There you go.
Same for email as well.
That's right. Yep, username is what's in GitHub. Cool. So after you do that, you can try the commit again. Yep,
Is it safe?
and it'll work.
Oh, sorry.
That's all right.
Is it what's the word? Letter case sensitive? Does
It is.
Okay.
Jeff changed his, so he did a commit and it seemed to work, and then
Yeah.
he changed his name to limit his GitHub username.
Yeah.
Does he need to do that again? Or is that-
So right now, if you look at Git log, Jeff.
So git space log.
Yep.
Author,
Yeah.
first command.
So does it show the right name next to author, or
Yeah.
the
Well, the author is my name with a space, but my GitHub doesn't have a space, so I just changed it.
Right. Let me see what it looks like for me.
Just a quick question.
Yes.
Well, it says
No. See, it should be.
I've got here permission denied for the key, even though I've got the correct public key in there. And I've also done both usernames there, which is the same, give to sec.
In that session.
Right. So it looks like you did a sudo, which is going to SU you to root,
Very first.
and your
It's just
key
that
is.
it wasn't giving me the permission to do it before, that's all.
Try this. Yep. Say
There
yes.
you go. Yeah, it's just before it wasn't
Yes.
letting me even do anything.
Okay. So this is because you.
I know it. I can
Okay.
just redo it.
Okay. All right.
Now I know.
All right. Okay. So yours is actually associated with the wrong name. Don't worry about it too much. From now on, you should be all right.
Yeah.
Okay. Okay. So now we've got it committed. I think everybody has it committed to their local repo now. So if you did have that error and you ran the git config, you should rerun the commit. Okay. You should rerun the git commit -m if you had that error about not having your username or email set. Yes,
So
Jai.
it's get commit dot
-m.
dash.
Yes, and then quoted message. Now, we still, though, haven't pushed it to GitHub. And if we look at git remote -v right now, there's nothing. We have no connection from this repo. Even though we cloned it, it does not make a connection, okay? A clone does not create, I'm sorry, we didn't clone it. Even though we did a git init, it does not create a connection, okay? A clone would have created a connection, but because we did a git init, that doesn't create a connection. So we have to explicitly create the connection, okay? So we're going to do that with git remote add. We're going to add a remote connection. We're going to name it origin because that is the convention, that we name our primary connection origin. And then we're going to paste in, let's go back and grab it again because you may have lost it by now. We're going to paste in the string that we copied from GitHub, the SSH string. Okay, copying the SSH string, we're going to paste that. So git remote add origin and the string, the SSH connection string. Yep? Yes, Jai?
I just tried to commit again. It said on branch master, nothing.
So I think because your commit succeeded, right? You said you didn't get in there, so it's okay. It's
I thought
okay.
that might have been, but I just wanted to double check it.
Absolutely. Okay, so we do a git remote add origin and the string. Now if you do a git remote -v, you should see that we have an origin connection. So git remote add origin, and then you'll grab the string from your GitHub. To GitHub. And just copy that. And then go back and paste it. So when we do this step here, that's when we're actually connecting what's in our laptop to that remote GitHub repository.
Yep.
Yeah? No, just creating the connection still hasn't put anything in that repo. How do we put stuff in the remote repo? Does anybody remember? That's right. So we're going to do git push. Now, you could just say git push, but don't. Please don't.
Oh.
So,
You gotta add the message, right?
no, not a message. Git push takes two arguments. The first one is the name of the connection that you're pushing it to. The second one is the name of the branch that you're pushing it to. By default, it will push to origin master. So you could just say git push and it'll push to origin master. But that's just sloppy because when you start to collaborate and you're pushing stuff into different branches, into different repos, then you can get really lazy about just saying git push. And then you forget that you did that, and then later you're like, why aren't those changes there? I know I pushed them. What's going on? And it's because you just said git push and pushed it to your origin master when really you meant to push it on this other branch, maybe on this other repo, right? So if you're always in the habit of just typing git push origin master when that's what you mean to do, is to push it to origin master, then you're just always being really intentional about your pushes. So I promise you, having some intentionality when you use git from the command line will save you tears. It's really easy to get mixed up in git and put stuff where you didn't realize you put stuff, and I thought I put it there, I was sure I did. But if you're always really explicit, then you'll save yourself some tears.
If we wanted to push to a different branch, we would instead of an origin master, do origin and just the name of the other branch.
That's right.
So what is the name of our branch currently?
Master. Yeah. So by default, unless we create another branch, we always only have master. So when we do a git push origin master, this is going to test our SSH connection, number one. And if it's the first time you're using it, it'll prompt you. It'll ask you to answer yes or no, and you should type yes. And that's just SSH. So SSH has to authenticate, wants to check with you that the host you're connecting to, you meant to try to connect to this host. And once you say yes the first time, it'll add that host to your known host in your .ssh directory. So you only have to say yes to that once for each each host that you're connecting to. So yes? Okay. Yes.
When things work.
Okay, so this could be a problem with your SSH connection. So you copy your SSH. I mean, did you copy your SSH public key to Git settings? So you can do it
So where do I need to go? To my profile? Your repository? Do I go to my repository? Where was that? Wherever should we go? There, your repository?
Okay. So if you're on the Coder Academy network right now, the push won't work over SSH. Okay? So one thing we can do is you can switch to say wireless, or I'm going to show you another thing to do. If we instead, or in addition to, add this connection,
So I can push wherever I want.
and push over this one.
So I could push it around.
You have to work out the way to do it. You have master branch. You keep the master branch, you make the working color. And then like make the second branch for each branch. So what about I don't know if it's getting why it's super mystery. That's why.
No, I accidentally uploaded a lot of stuff. And I should just have it so I'm like, it doesn't everything.
It's like even once you've
The second branch is where you build on the lost once you make the sentence right,
still, it's still
You'll put it to the market. But if you're not 100%
I was still putting on the start, and then we start working on it.
Yeah, I think that's, I don't want to do like how much.
Well, no, I'll be creating a game on Windows, so I'll use
Visual Studio.
for the C sharp and
Basically, like, it's what you call it. In the red bar with the browser, which is why we put the highlight for it. It's the same as
but you do need the bar, so it can be read by web page and do C sharp. So if you were to create a web client game, you would write it in C sharp.
Undo your proxy, and there's no save language network, so that was
kind of accurate, so what we're using.
Yeah, because the original Rust was created using a web client. Yeah, it was a web client. I'm missing it. But it was a web client and then moved over to legacy.
What's the show?
Oh yeah, I remember that.
We play Yes. I remember that. We were playing that as well.
That was like
And then Shrek in the final one.
All right, did everybody get that pushed up to your repo? Hello. So now if you go to your repo and you refresh the page or click on the repo name, you should see a README there in GitHub. Does everybody see that? Is that good? Everybody got there? Okay, cool. So that's how we create a repo, and then now we can make changes to the stuff in that working directory. We can add files. We can follow that same process: add, commit, push, and we can update what's in this repository. Okay. Let's see what else we have to talk about. So we talked about all of this. Okay. Let's make sure. Does anybody watch Archer?
Yes.
Oh my gosh. Oh my gosh. Oh wait. What happened? Yeah. Oh wait. I love Archer, sorry. So the way Git works, honestly, is very simple. It is not complicated, okay? It's really simple. But it's so easy to get confused and to mess things up, and it can get you in a state of panic, particularly if you're working against a deadline and you're trying to get changes in, and then suddenly things aren't working, and you pulled in your latest repo and things are broken, you don't know why, and it won't let you commit because you get these messages that say you can't commit because your behind or ahead, or you can't push because your repo is behind the remote repo. All these things can happen, and if you don't understand what's going on, you can get really flustered by it, and do what that first comic said, which is just like trash it and start over again.
Not like maybe like people use the Git GUIs.
So using Git GUIs can minimize problems because it forces some convention about the way you're doing things. So it'll prevent you from doing things that might hurt yourself, and it will force you to do things in a proper way, but it's not going to be completely idiot-proof. You still can get yourself in trouble using a Git GUI. And I still feel really strongly that it's worth taking the time to learn how to use the Git command line so you actually understand what you're doing and you actually understand how you're interacting with that repository. If you go work on a development team and you feel comfortable in Git, you'll be like some kind of wizard on a lot of teams, because there'll be so many people who are like, I just run the commands and then hope and pray it works, and if not, I trash it and pull down the repo again. So, yes.
Like avoid a lot of the confusion, having like a visualized like a bunch of branches and stuff. That can avoid a lot of the confusion.
It can, but I still feel that if you're really intentional about what you're doing, which I think you always should be when you're working on source code changes, being really intentional about what you're doing, really paying attention to what you're doing, then you don't get into trouble. I really don't ever have problems with Git, but so one of my aims in this course is to have you leave feeling completely comfortable with Git, so it's just not a problem. Because the thing is, again, if you go to a team, or if you're comfortable with this one GUI, because they're all kind of different, if you get comfortable with this one, they may not use that one, and then you've got to use something else. And then you get flustered and worried and confused because you're not comfortable with this Git GUI. And that should not be something that gets you flustered and confused. If you're comfortable with Git, period, you're comfortable with it on the command line, then it's never going to bother you if a team is using some different Git GUI. It's just never going to be an issue.
I find it confusing when I see 30 different, 40 different branches in a single row.
Absolutely, yeah.
The visualization helps.
Yeah, it can. It can, for sure. Yes, you sure can. And you can do a git branch-r to see the remote branches. So I'm also, I'm really biased to the command line, and that'll keep coming out as I teach this course because I spent so much of my career working on the command line. So I feel more comfortable on the command line. I always, I developed a distrust of GUIs, early in my career because GUIs are full of bugs, So sometimes you're fighting with something in a GUI and you're not even doing anything wrong. It's the stupid GUI has a bug, So that's another reason that I'm a bit biased to command line. Now, some GUIs are really well written, but most of the software, I'm going to say all of the software that exists in the world is buggy. So when you have a GUI, you're just adding bugs on top that you don't need. So I'm all for using GUIs where it's appropriate. It's fine, but I think it's good for us to get practice with this. So Git status, you saw me using Git status. It'll compare your working directory to your local repo, and it'll show files that have been added, modified, or deleted from your working directory. So we saw that. Git diff we haven't looked at, but you can use it to show exactly what was changed. It's just the output is a little bit confusing, so I don't show that on the first day. Git add we learned about with a dot will stage any changes in the working directory from this directory down. Git diff cached will show differences that are staged but not committed. Okay, so this is just sort of a reference for you. Okay, you're going to have these slides. You can look back at them anytime. We looked at committing. Now, you don't typically have to do this. You don't have to do this with Origin Master usually, because Origin Master is the default upstream repo and branch. But If you want to commit to another branch and have Git automatically understand that that's a branch you're pushing to, then you have to use the -u, which is shorthand for --set upstream. It's just shorthand for that command. Don't worry too much about that right now. Okay, and that's just the summary. Good stuff. So don't worry if you're still confused about what we did or all those commands. Really don't worry, okay? It's just to introduce you to these things. We're going to practice this stuff, the stuff that's in these slides. We're going to practice it every single day because you're going to have morning challenges every day starting next week on Monday. The morning challenge on Monday we'll do together in the afternoon, so it won't be a morning challenge, but every day after Monday it'll be a morning challenge and you'll follow the process yourself. And you won't understand it, some of you, the first 5 times that you do it, and that's okay. You'll ask somebody next to you for help, and then you'll just practice it over and over again, and it'll become second nature and it won't be a problem. I'll encourage you that when you start doing afternoon challenges, Canvas challenges, once you're comfortable with this process, that you create a repo to store your Canvas challenges too, just to keep all of your work somewhere, right? Because what if your laptop dies and then you'll be sad that you lost all your work? So if you push everything that you do up to a repo, then it's there in the cloud, nice and safe, nice fluffy safe cloud. So we'll just, and it'll give you more practice with Git, right? If we push everything to a repo, then we get more practice with Git. And then if you start doing stuff that you're really proud of, that you want to show off to friends or family or potential employers, you can just point them to your repo in GitHub. Be like, hey, check out my stuff. It's out here. And when you go to interviews, you can bring your laptop and you can show them your repo and be like, look at this cool thing I made. See, it's in my Git repo. Look how cool I am. So we'll just get tons of practice with it, and it'll become second nature, and we'll feel like, wizard developers before you know it.